Thanks, Sue. I'm delighted and honoured to be Jane Lubchenco. I think she's a terrific scientist. I think what she tries to do within policy making, I think, is brilliant under very difficult conditions. And it's a great pity that she isn't here instead of me, in many ways. I'd like to start off with some decisions that have been made recently. So, recently, you used to be able to take ash seedlings or ash seeds from Britain, take them on a holiday to Central Europe, to the area where there's Chalara, ash dieback disease, and breed them and mature them because it's a bit cheaper to do so, and bring them back. And we now have this widespread over our country. There's been a big push towards growing biofuel. In Australia, they introduced cane toads to get rid of the pests in the sugarcane. We routinely subsidize fisheries, even though we know in doing so it reduces the overall yields and it reduces the profits and it has environmental consequences. And then, thinking a bit more broadly, we decided to invade Iraq based on the existence of weapons of mass destruction that could hit us in 45 minutes. And we had economists who said that the risk of you defaulting on a mortgage is independent of anyone else doing that. And if you then cluster those together, those combinations are safe and that we can bet the world economy on that issue. So I don't actually agree with all of these decisions. What I want to do is talk a bit about how decisions are made and why there are problems with decision making. But I should say that I think a lot of decision making is good, is sensible, is evidence-based. There are lots of practitioners and policymakers that are doing this job very well. I'm going to talk about how we can improve it, but a lot of it is already good. So we know how you make decisions, and it's straightforward. You're told of the problem, you decide what the options are, you review the evidence, and then you just do what the evidence tells you to do. Everybody knows that. It's widely propagated in the media. This doesn't work, and it doesn't work for two reasons. One reason it doesn't work is that the evidence is always more complicated. The questions are more fragmented, and the evidence is normally not perfect. It doesn't apply to your situation. There are biases in it. You need interpretation to doing so. You can't just take the evidence and apply it. The second reason why it doesn't work is that you don't just take the evidence and apply it. You've got to be honest and accept that there are values, there's politics, there's social considerations, there's economics, there's waiting for the right political opportunity. There are all these other factors that very much influence when decisions are made. So this model just doesn't work. And it's particularly the issue that we need to have experts to interpret it that I think is important. So I think this is really a more realistic version. You're told of a problem, you think of what the options are, you then review the evidence, you then consult an expert, perhaps internally or externally, to say, well, what do you think of that evidence? You then decide whether or not to accept that opinion. You discuss the options, you then agree on what collectively you're going to do, and then you decide to act and move on. I think that's a better description of the process. But I think there are a few problems. I don't actually think we do that bit very well. And that's a bit flawed, and that's not quite right, and we could do that better, and neither of those, I think, are ideal. Apart from that, it's terrific. So what I'd like to do in this talk is talk about some of the problems of the way in which we use science for making policy decisions, and think of some of the ways in which we could improve that process. First of all, being told of the problem. So in 2006, in George Bush's State of the Union address, he made a big push for biofuels, and the European Union followed almost immediately afterwards. And this was done partly for environmental reasons, in order to have a greener fuel. We now know that there are serious problems. We know that in terms of greenhouse gases, it isn't the solution that people thought it was. We know that there are major environmental problems with large areas of forest being removed. We know, and I don't want to over-exaggerate this, but it's a component of the problem of the food price spikes that there have been, and this just shows some of the civil unrest that occurred, which is almost always linked to price hikes. So it was a factor contributing to that. So I'd like you to stick your hand up if you hadn't got your PhD by 2006. So either you were working on it then, or you've been doing it since, or you haven't actually got a PhD since. So it's in your interest, so stick your hands up. So now all of you are innocent. The rest of us, we were on watch. It was our sort of responsibility to see this problem, to recognize that it's something that should have been done, and made sure that there was the research in place. So when this policy came along, we had the knowledge to make the decisions and not do what we actually did, is make these fairly unfortunate decisions and then have to backtrack on those. And I think we've made a number of other problems there. So this inability to see in the future, I think, is a major problem. So we're interested in finding ways of overcoming that. And this is what many of us call horizon scanning. And we run an annual exercise, one of a number of different things that are done, to say what are the future issues that are coming up. And we're quite pleased with our track record. Our luckiest was high latitude volcanism and Icelandic volcanoes 2 months before the Icelandic volcano went up. That was just pure luck. We've identified many other issues that have since started to happen. And just as an example of some of the issues we're identifying in the future, this is drilling. This is one from the last horizon scan we did. We can now have the technology to no longer have our oil platforms so they're constrained by having to be above the surface. We can have the whole process that's on the seabed. And that means we can be less constrained, and particularly we can now have this taking place under ice, and we can exploit the Arctic in a much more efficient way. And we can think of then the consequences of what might happen if we then have large-scale oil production taking place under the ice. Just an example of the sort of exercise we think about. And another thing we do is we say, what are the big policy issues that are coming up? So we publish this paper in the British Ecological Society Bulletin every year. How many of you are members of the British Ecological Society? Again, stick your hands up if you are. Now then, look around for someone who hasn't stuck their hand up. Remember them. After this, go with them to the stall and make them a member. Because it's in your interest to do so, the British Ecological Society has this mad scheme. If you then get someone to be a member, then, and your name's pulled out of a hat, then both of you will have free lifetime membership for whatever deal you've signed up to. So if you've already got all 4 journals, you'll have all 4 journals for life. So grab someone, or if you didn't put your hand up, grab someone who put their hand up and go and become a member. So anyway, so each year we catalogue the policies that are taking place, and our ambition is to make scientists more aware of the policy environment. But it's very interesting that policymakers actually find this very useful as well. Identify the options. One of the things that really strikes me is that if you look at policymakers, they say, well, let's look at some options, but they always look at a subset of the available options. And I think that's a major problem. So one of the things we do is what we call solution scanning. We say, what are all the possible options in a given field? So we've done this for regulating ecosystem services. Here we've done it for the problems in the marine environment. And here's just a subset of it. This looks at some of the fishing issues. So it says, if you want to avoid bycatcher seabirds, In trawls, here are the 3 options we know of. In gill nets, here are the 4 options. In long lines, here are the 16 options. We start off by listing all the possible options that people know of. So here's the option scanning for predators. You'll be tested on this on the way out. So do policymakers know about this? And David Williams is the lead author in this exercise. So Jessica Walsh asked a group of 120 policymakers which of those options they'd heard of. And they've all heard of removing predators or controlling predators, but most of them have heard of about half of them. So there's no other option that everyone else has heard of. And some of the more obscure ones, like we have a fierce program on the Today program on Radio 4, our news radio station, and you can play that to keep away predatory animals. I'd be frightened if I had John Humphrey shouting at me. And that's actually used by some conservationists. And there's putting snake skins around nest boxes. Very few of them heard about that, but there's actually published research to show it works. So this shows that they're unaware of about half of the possible options. They use quite a range of those options. They've almost all used controlling predators, but all of the options have been used by someone, even these obscure ones of putting mirrors to get rid of great spotted woodpeckers, or ultrasonic devices, or cat curlew, or land dung, all to scare away cats. And we've assessed the effectiveness of these interventions, and the likelihood of them taking them up is greater if these are effective or if there's good evidence. Now, why I think this is interesting is we are the experts on pulling together the list of these interventions. So we published a book, we've pulled together these interventions. Since we've done that, we keep hearing about new interventions. And the advantage of this system is you can then keep updating it. We can then have a list of the possible solutions, and we can keep adding more and more solutions to that, so that when you have a problem, you can say, here's the total solutions we know of, rather than just randomly picking a small subset to decide amongst. So the 2 options we've come across since is you can put up stakes to stop gulls from predating your terns, or you can feed your pigs in more efficient ways in order to reduce the problems of crows coming and predating nests nearby. And we think it's very important that this is done by an outside body. If it is done by, say, government, they are then recorded as having considering that issue, like something like cat curfews, the idea of not letting out your cats at night. If you have that on a list, a journalist would say, are you considering that? And you've either got to say, well, actually, it's on our list of options, which becomes a newspaper headline, or you end up denying it. It's much easier if you have an external body that's looking at all of those issues, and you can just say, well, they might be thinking about it, but we're not at the moment. So it's much better if you have external people thinking about this. Reviewing the evidence. So I was brought up using Dr. Spock's book, along with 19 million other families. And one of the key issues is, do you put your child to sleep on his or her front or back? And Dr. Spock knew the answer. There are 2 disadvantages to a baby sleeping on his back. If he vomits, he's likely to choke on the vomiters. That kind of makes sense, So, if you're face down, the vomit will go out and you won't choke. Very sensible. Also, he tends to keep his head turned towards the same size, usually the center of the room. This may flatten that side of the head. It won't hurt his brain, and the head will gradually straighten out, but it might take a couple of years. If you start early, you might be able to get him used to turning his head to both sides by putting his head where his feet were the time before, each time you put him to bed. So because of that very sensible reason, and that rather loopy reason, he makes this suggestion: I think it's preferable to accustom a baby to sleeping on his stomach from the start if he is willing. And that just became the standard advice. In the 1990s, there was a systematic review of the evidence, and it said the evidence is overwhelming. You want children to go to sleep on their back. They're less likely to suffer cot death if they do so. And that resulted in global programs to bring that about. When they did that work, they also did the analysis to say, well, when did we first have the clear-cut research that gave you that answer? And the answer is in the 1970s. And you can then do the analysis and say how many babies died as a result of us not implementing the science that was already known. And the answer globally is about 60,000. So it's hard to imagine anything more powerful and more important to us than stopping babies from dying, and yet we had the evidence in place and we didn't use it. And that I find quite remarkable and quite astonishing. And it's because of that sort of problem we've had the revolution in medicine, so it has completely changed. So we've stolen the ideas from medicine. In medicine, your doctor has a book, clinical evidence, a website that says, here are the possible interventions, here's the evidence that tells you whether or not they work. And we've done the same for bees. We've said, what's the evidence? What do they work for 220 interventions? And for birds, for 330 interventions, and for farmland, and for bats, and for amphibians. So bees, birds, European agriculture, amphibians, and bats are all complete. And that's effectively equivalent to 750 reviews of interventions. We have another 3 aspects of ecosystem services where we reviewed quite large parts of the topic. And then there's people around the world that are looking at Israel. Stuart Pym and his team are looking at carnivores, people looking at plants, some work on invasives, Galapagos invasive, forests, and wetlands. So there's a global team of people trying to pull together that evidence, and we want to pull together the evidence for the effectiveness of interventions on all habitats and taxa. So why does this matter? I'd just like to give a couple of examples. So everybody knows one of 2 facts about nest boxes for bumblebees. Lots of people know that it's a very good thing to do, and you can buy, lots of conservation organizations sell them. Some people have spoken to Kevin Gaston, who's tested these, who's shown that it doesn't work, and people normally know one of these 2 facts. Either it is great, or it's a complete waste of time. If you then actually review the literature, it turns out to be a lot more complicated. It turns out there's actually 6 studies. It turns out there are 3 old studies in North America that work. There are another 3 studies in the UK that find it doesn't work. So we then start asking questions. Is it differences in the bee? Is it a difference in the way in which nest boxes are designed? There are studies that look at underground nest boxes, and those in Canada found they seem to work North America found they seem to work pretty well, and even in the UK they work better. In New Zealand, with introduced bees, the older the nest box is, the more it is used. So we can take these very unsophisticated statements, and because we've got the evidence, we can improve our decision-making and decide on how to improve it. And just another example, much the same. We know you should plant field margins for bees, and it turns out that it all depends on the detail. That if you just leave them unsprayed, well, that's actually a complete waste of time. If you let them to naturally regenerate over time, it only really works if you get thistles, and often the farmers remove the thistles, in which case it doesn't really work. If you use seed mix, it's great. If you use forage mix, it's even better. If you sow with grasses, then the bees can nest too. So we can move from very broad, it does or doesn't work, to much more sophisticated indications of what we can do. I was very impressed by this study. So the researchers watched clinicians with patients, and they spoke to their patients, and they gave their diagnosis, and they gave the recommendation, and then the patient went out. And then the researcher said to the doctor, are there any research questions that you would like to have answered? Is there any more information that you would like? And very often they said, yeah, I'd like to know, is this more effective than this, and other bits of information. And they then went away and researched that, and then they came back to the doctors and said, let's go over that case again. And they took out the notes, and they looked to see what they decided, and then they looked to see the questions that they were interested in, and they said, well, here's what the published literature has to say about the questions you're interested in. And on 14% of the occasions, the doctor would say, well, now I know that, I'd actually change what I'm going to do. So this might be out of date. This is an old study. Medicine, the evidence-based medicine's moved. But certainly at that time, it meant when you go to your doctor, there's a 1 in 7 chance that you're being given the wrong advice because the doctor doesn't have sufficient access to the published literature. Nice little thought for you next time you're in the doctor's surgery. The question is, does the same problem apply in conservation? So Jessica Walsh, again, has taken her group of practitioners. These are practitioners who are professionals and they're involved in dealing with the problem of predators on species of concern. So the people that, in theory, know about the science and what's happening. And at the time, the bird synopsis was a secret document. It's now publicly available. And so she then, after she did her first survey, she then gave it to them and said, now you have this description of the literature, would you change your mind as to what you would do? And on 46% of the interventions, the practitioners said they would. On 12% of the interventions, as they said, they'd be very likely to do so. And they're behaving in a sensible way. We've ranked these by effectiveness, judged by a Delfi technique. So these are very effective, and they're much more likely to use them, and these are very ineffective, and they're much less likely to use them. So that shows, and I find this an astonishing piece of work, that shows that the lack of access to information means that practitioners are not making the decisions that they would if they had full access to this literature. And it's the literature that supposedly is publicly available. This isn't difficult to, well, it is difficult to obtain. This is supposedly information produced for them. So not everybody changed. Who's less likely to change? Well, it's the more experienced practitioners change less. And there's one of two reasons for this. The reason I like is that the more experienced practitioners, they just know everything, and they have a good knowledge of the literature, and so they don't change. The theory Jessica likes more is that they're just less likely to change because they're old and stubborn and that sort of thing. So does this affect policy? So this is a report produced by the European Union that looked at the bycatch of seabirds and looked at the evidence for the effectiveness of different interventions and then used this as a basis for European Union policy. And it's a nice study. It had 17 interventions, tested 36 of them, reviewed 29 of them. You can ask, how much did that cost to do? Sue, how much did this cost to do, would you guess? Well, guess. 360-page report. 100K, very good guess. Oops, wrong figure. 100, yeah, certainly tens of thousands, and my guess is pretty similar, 100,000 pounds roughly. You can say, how long would that take to produce? It certainly took 6 months or so. Anyone I've spoken to, people in DEFRA, people in the European Union, have guessed that the time from thinking of the idea to it landing on your desk is probably about 5 years. It's certainly months, it might be years. Now, our bird synopsis covers the same area. Our bird synopsis, and you can compare them. So we looked at how many interventions did we come across. We actually came across slightly more. We came across slightly more papers, and we had slightly more peer-reviewed papers. But they're both pretty good. I'm not saying ours is enormously better. The critical thing is that our database is available online, and what we're doing is we're taking the time from months or years to minutes. We're taking the costs from Sue's £100,000 to free. And that's the big ambition we want to do. We want to take the review time for ecological information down to minutes, because that's the way we work nowadays. The way we work is more or less if you go to your doctor and you say, I've got malaria, and they say, I'm terribly sorry to hear that. I'll work out what's best. I'll do a review and give you the information in 3 months' time. By the way, have you got £100,000 to pay for it? It just doesn't make sense. We need to have all of that information there, paid for by someone, so you can access it immediately. So next, this critical issue of having to involve experts. So the information is never entirely suitable. You always have to have experts to interpret this. It took me some time to get used to the dress sense in Cambridge. This is a typical day in the lab. I'm delighted that Mark Bergman came and stayed with us for a few months. And we became very interested in science and policy making and ways in which we could make policy making more efficient. And one of the things that he's particularly very interested in is looking at the fact that experts are actually pretty hopeless. So this is the prediction of experts, and this is the actual experts. And this shows for weather forecasting, that's pretty good. If you look at various medical issues, such as this is whether or not you've actually got pneumonia from the medical evidence, and what your predicted lifespan is from various studies, it's very poor. And the study after study showing that experts are pretty hopeless at making decisions, making predictions. And the reason for this, you think, well, that doesn't make sense. There's two caveats. Firstly, there's a point at which that no longer applies. You know, if you just take someone completely off the street who hasn't heard of ecology, then they're not going to make sensible decisions. It's once you've got above a certain stage, a PhD say, there's little effect. They're less good. Secondly, what actually seems to happen is that we do have areas of expertise that we know about, but it is very narrow. But because we've got that narrow expertise we know about, we feel very confident about commenting on a wide range of experts and think that we're expert on those, and the evidence is that we're not. So I'd like to describe this study that Mark did. He asked various people, brought them together in teams, and each of them had to give a 1-minute description of their background. And then each of them had to assess how expert they thought they were and how expert they thought everybody else was around the table. And it's very interesting that if everyone else thinks you're an expert, then you also think you're an expert. So these are people that they didn't think they were experts, and no one else thought they were an expert, and they didn't think they were an expert. These people, they thought they were experts, and the rest of the group thought they were experts. And the other interesting thing is it's sort of more or less a linear relationship, except if everyone else thinks you're good, then pretty often you just think you're terrific. Now this is a really, really nice study. It shows that there are 3 correlates of expertise. The first is the sort of things you've achieved. So if you're president-elect of the British Ecological Society, that's pretty good. The second one is your number of years of practice, and the more practice you have, then the better you are too. So that's pretty good. And thirdly, you want to be male. So this is a really nice study, and I think it's great. Unfortunately, should have left it at that stage, but unfortunately then tested to see what experts actually know. So this line, we want the solid line and the dots, look at that. This is how accurate their predictions are, and a value of 0 means that they get it exactly right. And this is everybody's assessment of how good you are. There's no relationship really between how good you think you are and how good everyone else thinks you are and how good you actually are. And there's no relationship with how experienced you are, and it's a bit better to be female. The really interesting thing is that, and the study after study have shown this relationship. It's very difficult to get measures of expertise that actually make sense. So experts aren't really to be trusted. So there's Kretinsky has been studying this, and I love this bit of text. He talks about the fact that you can have inspectors as experts, and he talks about them as fee-hungry knaves, tithe servers, dodderers in their dotage, yet all these and all sorts of characters can pass inspections. It's the same message as the graph, that there's very little evidence for what an expert is. It's very difficult to judge an expert. So if you want to consult an expert, just using the mean of a group of people is normally about as good as using an expert, and it's good to have a diversity of people. So how do we discuss options? This is Delfi, and this is the Oracle of Delfi. I'm sure you all know about the Oracle of Delfi. She was this woman that lived in this temple and absorbed sulfurous fumes, and when people gave her for advice, she gave this incomprehensible bits of advice, and they went away perplexed. And somehow we've used this term for what's the most sophisticated decision-making process we have. I don't quite know why we call it the Delfi technique. But the Delfi technique says you ask people what their prediction is, anonymously. You give everyone the range of scores, and we say, do you want to comment on that? And the idea is that if you have an extreme prediction, you should really either say, well, okay, I've got that wrong, I think I'll agree with everyone else, or you should argue your case. You should say, I think you're all wrong because of these issues. And then and then you have another round of anonymous voting, and you keep coming back and back and back and doing that. And the evidence is that that is overwhelmingly the best way of making decisions. So this is the results I showed you beforehand. If you then apply a Delfi technique and get people to make their predictions once they've heard the comments of everybody else, they're a lot better in doing so. And all the studies there are show that the Delfi technique is the best way of doing it. The really interesting thing is then expertise becomes even less important because you've shared all that information. The information's available for everyone, and the skills turn out to be very different. It turns out that experts are often quite poor in making decisions because they're over-influenced by their own knowledge, they're over-influenced by their own research, they're over-influenced by things that they've seen. And the people that are most skilled are often people that don't have that much specific knowledge, but particularly have those softer skills, are very good at judging people, judging information, balancing conflicting information, and they seem to be the real experts, the real best predictors here. So the Delfi technique is a technique that we use a lot. We use in a slightly modified version in that we traditionally have a round of voting, we provide information, have a round of voting, then have an open discussion, and then have another anonymous round of voting. So this is one of our horizon scanning exercises, and this is the discussion taking place. Everyone seems to be sniggering at the time anyway. The discussion taking place as part of that process. So this is just an example of the sort of way in which we use the Delfi technique. So we did a review of all the interventions in European farmland, and we brought all of those together. And that meant we could do a very quick review of the sort that I've described, because it just takes minutes to extract that information. We then said, how confident are we about various interventions? And particularly, we looked at the interventions that the European Union was thinking of for their reformed common agricultural policy. And they're going to spend perhaps 6 to 8 billion euros a year on this every year. I guess that's what you do every year. 6 to 8 billion euros a year. So it's kind of nice to know whether or not it works, but it seems that they hadn't actually reviewed the evidence. If you do review the evidence, so we took our team, we looked at these possible interventions. These are the number of studies we found and we included in our review. We gave them all that information. We said, how certain are you about that information, and do you think that would work? And it showed that of the 3 interventions that are underpinning 30% of CAP spending, we were far from confident that that would work. There are other interventions that we thought were much more likely to work. So we're deeply worried about the decision making. So this has a number of advantages. It is transparent, it's traceable, and it's repeatable. And that means that you can take that information and that you can, you know what the evidence base is, and you can then decide what to do. And we're just looking at the new model for IPBES, and what they're going to do in IPBES is they're going to do a quick review, taking about 3 months, and then have 1 year and 3 quarters to then edit that and look at that. I think that is deeply flawed. I think what you need to do is have a proper review, have proper, independent, transparent, traceable reflection of what the evidence means, and then produce that, and then have the global community look at that. I think that's a very different way of working. So how do we agree collective decisions? So then if you look at the evidence, there's a number of clear rules that voting is always better than not. It's better if it's anonymous. There are different means of voting, and that makes a real difference. Models are usually better than people. So if a model is more likely to give you the right diagnosis than your doctor is, but patients don't like it and doctors don't like it, but that's just the truth, and they're more likely to work out the outcomes of court cases, people aren't very good. And it's better to have a structured approach. It might be a structured planning approach or a structured decision-making approach. Then finally, how do you act and move on? We showed that weather forecasts are actually quite good, and bridge players are quite good. And the reason for this is they have a short-term feedback. So if you get the weather forecast wrong, you know the next day. In most of these other areas, there's no real feedback. And it seems we can provide that feedback. We could find ways of giving feedback on the grants that you've produced, or the people you've recommended, all those sorts of things, and say, or the papers you've accepted, let's give feedback on how people have done. We could provide coaches. So we have coaches in sports, quite obviously, but Atul Gawande has talked about the option of having coaches within medicine that they now have for surgery. And I should say, if you're a practitioner and you're to only, conservation practitioner, and you're to only read one book, I think this is the best book. This is the best conservation book there is. It's really interesting. So we could do the same in science and policy. We could say, this is the information you gave, this is what it means, this is what you did. So what's the way forward? Everyone says we need to measure the success of projects, but if you look at it, projects always succeed, they're never repeated, it's almost impossible to measure the success, and that results in lots of unread reports. What I would say is what you need to do is break it down to the level of interventions, and in that case, it doesn't actually matter if some interventions work and some doesn't. It doesn't mean your whole project's a failure. You can repeat those interventions because they're repeated across projects. It's practical to just look at single interventions rather than look at whole projects. And I think if you have that, we'll have a better planet. So as an example, Andrea produced this very nice thesis, and he tested a whole range of interventions, and in his Viva, we looked at the cost effectiveness of this, and it was sort of orders of magnitude cost effective to do this work in terms of the money that was saved. We need a lot more work like that. And you can publish the results, so we can, we've got an online journal in which we encourage practitioners to say what the evidence base is, to say we're not interested in the long assessment of your information, the literature. We just want to know what did you do and what were the consequences, and we can publish that. This is a bit, the final point, this is a bit of real bureaucracy that clinicians use. It's a checklist to tell you what to do. It says, do you know who the patient is? Do you know what procedure it is? Have you checked that you marked the site? Have you worked out whether or not you have blood loss? Have you worked out, confirmed who the patient is, what the site is, etc.? And then afterwards, have you marked the labels, that sort of thing? It's a very bureaucratic, apparently pointless exercise. Being medics, they've tested this with a randomized replicated controlled trial. You're 17% more likely to survive if your doctors use a checklist like this. And the one I find particularly interesting is whether or not you've confirmed your name, whether or not you've all met each other. If your doctors have said hello to each other and said what they do, you're more likely to survive. So the question is, should we be doing the same for science and policy? And with the Centre of Science and Policy, we've been talking with various policymakers about saying, can we have a policy-making checklist that policymakers can then just routinely apply in the same sort of basis? So let's identify forthcoming new issues. Let's collate the evidence, especially interventions and threats. Let's aim to bring the review time down from minutes to from months to minutes. Let's provide independent assessment of the evidence using Delfi-type techniques. And let's improve the way in which we use experts. You have to have experts to interpret the information and decide what to do, but we can use them in a much better way. And let's learn from our actions so we don't repeat our mistakes. So I've ended on a rather negative note. I just want to say a couple of positive things. I showed this slide a couple of years ago at the BES, so I apologize if you've seen it before. So here's a display, a protest. What do we want? Peer review change. When do we want it? What do we want? Evidence-based change. When do we want it? After peer review. There's an increasing demand for this sort of activity. Politicians such as Obama are pushing for the use of evidence, and he's having major problems in doing so, but there's that increased interest. And then finally, here's my two daughters. The eldest one had a school report when she's age 10. And they don't know who I am. I've talked to them about birds, but they know nothing about me. But anyway, so this is what a report says. She's progressing well, but must take a more evidence-based approach. So there's something perhaps going on in the next generation. So I think the world is moving our way, but we need to find a different way of working, and we need to have the same sort of revolution as there's been in medicine, in conservation, in order for us to be more effective. Thank you.